Hi, we need to find the gradient of the given curve, and this is it. Y is equal to root x minus 1 over root x at the given, left the word at the given point on the curve, and that's when x is equal to 9. So go ahead and assign this f of x is directly equivalent to over root x. Now we can simplify this to make it root x over root x minus 1 over root x, which is finally 1 minus x to the minus a half. Now we find the derivative of f of x would be equal to 0 minus a half x to the minus 3 over 2. And this gives us one over 2 root x cubed. So that's our derivative. Now we need to find the gradient at the given point, and that's where x is equal to 9. So therefore the gradient of the curve which is dy dx is equal to 1 over 2 root 9 cubed, and this is equal to 1 over 54. So the gradient of this curve, y equal to root x minus 1 over root x, is 1 over 54 at a point where x is equal to 9. Very important to summarize what you've actually found, your result. It makes for a good understanding of what you've done and not just a rote differentiation. Thanks for watching this video. My name is Alistair Harris, and I'll see you in the next video. Bye for now. Hi, we need to find the gradient of a curve. Y is equal to x minus 5 brackets times x squared add 3 brackets at a point where x is equal to 0. So let's go ahead and simplify y. Y is equal to x cubed add 3x minus 5x squared minus 15. And we can rearrange that as x cubed minus 5x squared and 3x minus 15. So dy dx is equal to 3x squared minus 10x add 3. So now we have the gradient function, which is 3x squared minus 10x add 3. But we need to find what the gradient is when x is equal to 1. So at x equal to 1, so when x is equal to 1, dy dx is equal to 3 into 1 squared minus 10 times 1 add 3, which gives us negative 10. So we have a result that the gradient of this curve at the point x equal to 1 is negative 10. Let's go ahead and summarize this. So we can say, therefore, the gradient of the curve y is equal to x minus 5 bracket x squared add 3 is minus 10 at a point where x is equal to 1. Thanks for watching this video. My name is Alistair. Always remember to practice, practice, and practice some more. Bye for now. Alright, we're given this pair of coordinates and we're asked to find the line that passes through these 2 points. So first we need to find the gradient. So gradient m is equal to y2 minus y1, which is minus 18 minus 4, and that's divided by x2 minus x1. X2 value is 10 minus x1, which is 3. This will give us negative 18 add 4, which is negative 14, and divided by 7 will give us negative 2. So we know our gradient is negative 2. But how do we find c? Well, we know the equation of a line is y is equal to mx add c. M is the gradient, and x and y are coordinates of a particular point. So we'll use this point 3, comma, negative 4. So we have negative 4, which is y, is equal to mx, which is minus 2 times 3, add c. And this allows us to find c, which is the y-intercept. So we have negative 2 times 3, which is negative 6. Take away 4, which will give us 2. So c is equal to 2. If we were to write this in the form of an equation, we have y is equal to mx minus 2x add 2. And that's the equation of the line with these 2 points, 3, negative 4, and 10, negative 18. Here's another set of 2 points, and first we need to find the gradient m. That's equal to y2 minus y1, so that's 6 minus negative 3, divided by x2 minus x1. x2 is negative 1, and we're taking that away from negative 7. In the numerator we have 6 add 3, which is 9. In the denominator we had negative 1 add 7, which will give us 6. which simplifies to 3 over 2 as our gradient. And like before, we'll calculate using y is equal to mx and c. To calculate c, we'll use these coordinates for this point, -1, 6. So we have y, which is 6, is equal to mx. Our m is 3 over 2, and we're multiplying that by -1, so it goes minus 3 over 2 at c. If we rearrange this, this implies that c is equal to, we have minus 3 over 2 added to this side will give us 3 over 2, and this will be 12 over 2, which should give us 15 over 2. So our equation is y is equal to, let's write it over here. Our equation now is y is equal to mx 3 over 2x at c at 15 over 2. Scales y is equal to 3 over 2x at 15 over 2. And that's the equation of the line passing through these 2 points. Thanks for watching this video. My name is Alistair. Any questions, comments, please send them to me. Don't forget to like, follow or subscribe for more videos like this. Bye for now. Hi, this is Harris Maths. We're given this equation and we're asked to calculate the gradient and y-intercept. Well, first we'll clear the brackets and try and simplify this. So the numerator becomes minus x at 2y at x at 2y. And now we'll cross multiply here. So we'll multiply -2 by the denominator, and we have -8 minus 2x add 2y. Now if we simplify the left hand side, we have the x minus x and x cancels out, so we have 4y, and the right hand side becomes, we have a -8 and a -2x, so we'll write -8 minus 2x. The 2y now, we can add it to both sides, so let's do that all in one go. So we have 4y minus a 2y, which will give us 2y is equal to -8 minus 2x. If we divide throughout by 2 and swap minus 2x after dividing and -8, we have that y is equal to 2 into that will give us -x, and 2 into -8 will give us -4. So our gradient is a coefficient of x, m is our gradient, that's equal to -1, and our y-intercept, c, is equal to -4. Here's another question where we're asked to find the gradient and the y-intercept. We'll clear the brackets in both the numerator and the denominator and try rearrange and simplify this. First, numerator will have y minus 3x, and in the same swoop we'll clear the brackets in the denominator, multiply by 1, and we'll have it on the right hand side. So we'll clear the brackets to get minus 6x, add 2y, and anything multiplied by 1 is that actual thing. We'll rearrange this. If we add let's say minus y to both sides and swap sides, we'll have 2y, take away y, which will give us y on this side, and we have minus 6x, add 3x, which will give us minus 3x. Sorry, that was a mistake. We also moved the add in a 6x to both sides, so we'll have y as we said before, but we'll now move the 6x by adding 6x to this side, and that will be taken away. That become positive 6x on this side, and now we have 6x minus 3x, which will give us 3x. So the equation of the line is y is equal to 3x. We have m as the gradient, which is equal to 3, the coefficient of x, and c, the y-intercept, it's 0. And that's it for this video. Thanks for watching. My name is Alistair. If you have any questions or comments, please feel free to send them to me. Don't forget to like, follow or subscribe for more videos like this. Bye for now. Now that we have our 2 points, minus 1, 0 and a half 0, where the 2 tangents cut the x-axis, we can go ahead now and find the gradient. But how do we do that? Well, what we're told is that the curve cuts the x-axis at these points, so we know the y coordinate is 0 in both cases, and also the tangents. Now the tangents to a curve, if we want to find a gradient, it is at a particular point, and because they're tangents to the curve, the gradient of the curve will give the gradient of both of these tangents at that point. Again, if we were to have a curve like this, and we have 2 tangents at this point, so the curve, the gradient of the curve is common to the gradient of both tangents. So we go ahead and find the gradient of the tangent. We do know that dy, if you recall in the first part, that y is equal to 2x squared and x minus 1. So dy dx, the gradient, is equal to 4x add 1. And this is indeed the gradient of the 2 tangents. Well, let's find out what the value of these gradients. So this is gradient function, and the value at, we'll go for -1, would be 4 times 1 add 1, which is equal to -3, and at a half would be 4 times a half add 1, which gives us 3. So we know the gradient at this point, negative 1, 0, is negative 3, and the gradient at a half, 0, is 3. And now we could go ahead and find the equations of these tangents to the curve. So we call the gradient to minus 1, 0, negative 3, m1, and m2 is the gradient at the point a half, 0. Let's find the equations of the tangents. We use the formula y minus y1 to m into x minus x1. We have y minus 0 is equal to m negative 3 into x add 1. And this gives us y is equal to minus 3x minus 3. And using m2, so with that's m1, m2 equal to 3, we have y minus y1 and x minus x1, which gives us y minus 0 is equal to 3 into x minus a half, and this gives us y is equal to 3x minus 3 over 2. So now this is the second part. We've found the equations of the two tangents. So the first is y is equal to minus 3x minus 3, and the second equation of the second tangent is y is equal to 3x minus 3 over 2. Next, we'll find the point of intersection of the two tangents. Hi, we need to differentiate f of x. So f of x is 6x squared add x minus 1 over 3x, and can be rewritten as 6x squared over 3x add x over 3x minus 1 over 3x. Therefore, we have f of x equivalent to 2x add a third x minus 1 over 3 x to the minus 1. So dx of f of x is equal to 2 add 0 minus a third brackets minus x to the minus 2, which gives us the final result of 2 add a third, or 1 over 3x squared. Let's rewrite that so it's visible. 2 add 1 over 3x squared. And that's it. Thanks for watching. Continue to practice, and practice some more. Bye for now.